Welcome to Ask and Learn.
Hello and welcome to this video solution of numeric. Here we are given a mass is connected with a spring. Now this body is having mass m equal to 1 kg. The spring constant k equal to 100 Newton per meter, and the amplitude of oscillation is 0.1 meters, right? So initial amplitude equal to 0.1. Next, at the equilibrium position, we place a mass of 3 kg, so capital M equal to 3 kg over this mass, right? And we assume that both the blocks move together, and we have to calculate the frequency and amplitude of the motion. So here we have the total mass, let's say m dash equal to 3 plus 1, which is 4 kgs, right? The time period of motion is calculated as, for a spring mass system, is 2 pi root over of mass by k, spring constant. So if you plug in the values, we have equal to 2 pi over 5 seconds, right? And from this we can have the frequency of oscillation f equal to the reverse of time period, that is, or inverse of time period, which is 5 by 2 pi hertz, right? So we calculate this frequency, right? Now look, now we have to calculate the amplitude, final amplitude. So part A is done. Now part B. Now for that we need to calculate the velocity of this mass at the equilibrium position. This is given by equating the spring kinetic energy of the mass with the spring potential energy. So the kinetic energy of the mass is half m v square equal to half k x square, right? Or maybe half k a square we can write. The amplitude is there, so here we write a square. Now half of gets cancelled. Here we have v equal to root over of k by m a, right? Now we plug in all these values. This gives us v equal to 1 meter per second. Okay, so let us see. K is 100. The mass is 1 times A is 0.1, right? So this gives us 1 meter per second as the velocity of the small mass m. Now we have to calculate the final velocity of that combined mass, right? Now we have actually placed a bigger mass over it. Now we can calculate it using the conservation of momentum. So initial momentum is mv, and which is equal to final momentum. Now we have got the total mass m plus m, and let's say the final velocity is v dash. So v dash will be equal to small mass is 1 times the velocity is 1 by the total mass is 4. So 1 by 4 meter per second is the final velocity of this system. Now we have to calculate the amplitude of motion. Again, we will apply the same concept. Potential energy is equal to, okay, so we have spring potential energy that will be equal to the total kinetic energy of the system. So spring potential energy is half k x square. Now x is actually the final amplitude, we can say, and half m will be total mass m plus m. V dash is the final velocity square. So half of again will get cancelled. Now you have to calculate x, right? So x will be equal to m plus m by k. Okay, so here we have the root over v dash, right? So this gives us, if we substitute, then this will be 4 by k is 100 and v is 1 by 4. 2 by 10 times 1 by 4. This gives us 1 by 20, which is equal to 0.05 meters. Thus, we can say the final amplitude of motion is 0.05 meters. I hope this is clear to you and have a very good rest of the day. Thank you.